Hello everyone, welcome back. In this video, we will be discussing about the last problem of today's biweekly contest, count palindromic subsequences. The problem is interesting. Uh, you will, as always, we will start with very basic and we will try to build the solution step by step with intuition. And the problem is a bit tricky, so I would encourage you to stay till the end, and I'm very sure you will learn something new as always from this video. With that, let's get started. So the problem states that you are given a string S which contain only digits and you need to return the number of palindromic subsequences of S having length 5. Okay. So what is the subsequence? Subsequence basically is you can take you can given a string you can delete any characters from this string and the remaining string will be a subsequence of the original string. And what is palindrome? Palindrome is basically if you read the string from forward and from backward, both should be same. So you need to return the number of palindromic subsequences having length 5. Okay, so that's it. So for example, if this is a string, there are six possible subsequences of length 5. Okay, so for example, let's say 10330. It is a subsequence because we just deleted this last one and we formed this, right? Similarly, let's say if you delete one, this three, we will get 10301, which is a valid subsequence. So similarly, we will find out all valid subsequences, okay? And from all those valid subsequences, we need to find out how many of them are of length 5 and is palindrome. So these are the valid subsequences of length 5, and among all of these, only two are palindrome, which is 10301. So 10301 occurs twice because it can occur if you delete this three or this three, right? So because it occurs twice and this particular string is palindrome, we return 2. Okay. So hope the problem statement is clear. Now let's look at how to solve this. Now, as always, we will not jump directly to the solution. Instead, we will see how we can solve a smaller version of the problem. So the problem is says that you need to return palindromic subsequences, right? So before going ahead and finding out palindromic subsequences, it might be worth looking at if you are able to count the number of subsequences itself. Okay. So we will also forget about this length 5. We will relax this condition afterwards. So for now, we just need to find out, given a string and a subsequence, find me or return me the number of ways in which this subsequence can be formed. Okay. So we need to delete some elements from here, and finally this should be formed, and we need to return the number of ways in which this can be formed from this particular given string. Okay, so hope the reduced problem statement is clear. We removed palindrome. We said that this subsequence may or may not be palindrome, or let's just modify the example a bit. So let's say this is 301, so there is not palindrome now, and we just need to return the number of ways in which this subsequence can be formed from the given string. Okay, that's the new problem for now. Now think about it. You need to return number of ways in which this string can be formed from the particular given string. So what should be so what should you do with the first letter? Let's think about this. So this letter either should be present or should be removed, right? That's the only two possible criteria. Now, if this letter should be present, then this is the first letter of the formed subsequence, right? So if this letter is present, this is the first letter of the formed subsequences, right? So if this is the first letter, here we have first letter as 3, right? These two are not equal. So it is sure that we can't afford to keep this element, right? We have to remove this. Hope this makes sense. So basically, there are only two choices with the first character, either or with every character for that matter. Either you will remove it or you will keep it. Now, if you keep it, you can't change its position, right? Because that's the definition of subsequence. You can't change its position. The position should be there, should be intact. So if you talk about this first character, this either should be removed or should be taken. Now, if it is removed, then it's fine. That we don't need to worry about this. Like this is already removed, so this will not contribute anything. But if it is present, one is the first character of the subsequence that we are going to form. But we want 301 as the subsequence, and 3 is the first character of that subsequence. So we are very sure that we can't afford putting 1 in the, like we can't afford putting not removing 1 from our like from the number of ways which we are going to find, right? So we have to remove 1. Okay, so now let's say we decided what to do with this string. Now what's the case? The case is exactly similar. Find me number of ways in which I can form this subsequence, right, 301 from the reduced string 03301. So previously, what the question? The question was, find me number of ways in which I can form the subsequence 301 from the given string 103301. But now the problem is reduced to find me number of ways in which I can form subsequence 301 from this reduced string 03301, right? So that's exactly similar to the original problem statement. So hope you can see the recursion here, right? So what we are doing, let's just formalize it. Uh, we like with every character, there are two choices. Either it should be there or it should not be there, right? Now, based on what we do, we always reduce the string, right? And now let's just take an example. Let's say we don't we are sure that we can't afford these two, right? So that is sure. Now let's talk about this this particular string. Let's say this is, we need to find out number of ways in which subsequence 301 can be formed from the string 3301. Okay, so what exactly can we do? So this 3 can be removed or can be taken, right? There are again two choices. So if it is removed, then it's fine, right? But what about if it is taken? So can we take this? The answer is yes, because this time if we take this, 3 would be the first character that we want, right? We want the first character to be 3. And like if we keep this 3, 3 will be the first character. So basically, if we keep this 3, what is the new problem statement? The problem statement is now find me the number of ways in which a subsequence 01 can be formed from the string 301. Okay, so hope this makes sense. So basically what we are doing, every character has two choices. Either you will take it or you will not take it. If you don't take it, then it's fine. And if you take it, like you can only take it if the first character of your subsequence matches with that particular character, right? Now once you have taken it, right, now let's say you decided to take 3, so your first character is now done. So you're now the new subsequence that you need to form is 01, and the new string that is left is 301. Okay, so that's basically the recursion that we are that we are having. So basically, there are two things. One is the index in the original string. Second is the uh, index in the subsequence, right? Now, every like there are two choices. Either you will take this index or you don't take this index. If you don't take this index, it will be simply find me number of ways in which I can form the same subsequence with the leftover string, right? So basically, you will form the same subsequence sub of I, or starting from sub of I with the remaining string. Like you will just remove the first character, right? And the you can take the other path only if this index and this index are equal. And if they are equal, you will take the other path. Okay, so hope this makes sense. Let's look at the pseudo code quickly. uh, so what we are doing, as we discussed, we have two index. First is the index in the original string s. Second is the index in the substring, okay, or subsequence. Now if we have taken all the characters in the subsequence, or subsequence index is actually the last index, or subsequent index is crosses the last index of the subsequence length, then we say that okay, we found one possible match. Okay, so remember, we are incrementing it only when we are founding one thing, right? We are taking one thing and we say that we will be taking this character. So if it points to the last character, it means we have already taken something from our string which actually forms 301, right? So we will just return one because we found one substring, one subsequence that is actually equals to the given subsequence. Now if this is not the case, it means the index is somewhere here, right? So if it is the if index is somewhere here, but as index is at the end, like there is nothing left in the string. So what we are saying is, find me number of ways in which I can form, let's say, 0 1 from nothing. This is also not possible, right? So that's why we return 0. Now after these two cases, the other case is exactly similar to what we discussed. If we can decide to remove the character, and if we remove the character, we don't need to worry about anything. We will just say, find me the number of subsequences, number of ways in which the same subsequence, like same subsequence starting at some index, can be formed with the remainder string, right? And other case is, we take this character, we take the current s index character, and when we will take this s index character, only when this character matches with the subsequence character, or the first character of the subsequence. So we just check that if it is matching, then we have other possible choice, which is to match these two character and move forward. So for in this example, let's say this 3 and this 3 matches. So we can decide to take this character, and if we take these two character, the remainder string is 301 and the remainder subsequence that we need to form is 01, right? So that's what we have done. The remainder string is s index plus 1 and the remainder subsequence is sub index plus 1, and finally we return the answer. So hope this problem makes sense. So what we have just solved is, uh, given a string and a subsequence, find me the number of ways in which I can form this subsequence from the given string s. Okay, and we see that we are able to solve this pretty easily with recursion, because at every character we have only two choices: either we will take this character or we will not take this character. Now if we don't take this character, that is fine, but if we take this character, then we have to think about it first, whether this character, because we are taking this character, so this character would be the first character of our subsequence, and whether this character formed with the matches with the first character of a subsequence or not. Based on that, we will take this character, we will decide to take this character, and if we take this character, we will have another possible condition. Okay, so hope this entire solution makes sense. So now we are able to solve how many, or how many ways are there to form a particular subsequence from the given string s. Okay, now this was not the original problem was, we need to find out the palindromic subsequence having length 5. Okay, so now if you think about it, the problem is now simpler. We know, given a particular subsequence, the number of ways in which I can form that subsequence. We know that. We solved that just before this, right? With this particular, sorry, which this particular algorithm, right? So we know this particular thing, that given if I'm given a particular subsequence, I can count the number of ways I can form that subsequence. So because we need to find out the palindromic subsequence of length 5, the length is fixed, right? And the subsequence should be palindrome, right? Now, if you think about it, how many such subsequences are possible at all? There are only 1,000 such possible subsequences, right? And what are those thousand possible subsequences? You can just enumerate them all, right? You can just enumerate all those 1,000 subsequences. So you are forming a palindrome of length 5. So these two should be equal. Sorry, this character should be equals to this, right? And similarly, this character should be equals to this. So what are the like distinct things? So you can fill this from anything between 0 to 9. You can fill this from anything between 0 to 9. You can also fill this from anything between 0 to 9. But once we have done this, we have filled these three characters, the other two characters are fixed, because whatever you have put here, you are forced to put it here, because you need to form a palindrome. Similarly, whatever you have put it here, you are forced to put that at the end index as well, right? So basically there are only 1,000 such possible subsequences, right? And what you can do for each of those 1,000 subsequences, you can directly apply this particular algorithm, right? And you will just sum the contribution of all of these 1,000 subsequences, and you will get the answer, right? Now, what is the time complexity? Let's look at it. So first, let's evaluate the time complexity of this particular algorithm itself. So we will memorize it for sure. Now, inside this, we are not doing any kind of iteration. We have just done some basic arithmetic operations, some comparison, some addition, right? So only basic arithmetic operations are there inside the body of this function. So if we do memorize, then we will be calculating each state exactly once. So how many different states are there? So number of different states would be how many different possible value of s index can be there? N, right? The length of the string. And how many different possible value of sub index can be there? Let's say k. K is the length of the subsequence, right? So total number of possible states are n into k. And what we are saying is inside this we are not doing any heavy operation, just some arithmetic operations. So we can just consider everything as order 1. So the total time complexity of finding the number of ways in which a particular subsequence can be formed from the given subsequence is order n to k, right? Now let's think about it. So we are finding a subsequence of length 5. So here k is a 5, right? K, if you remember, k was the length of the subsequence. So here k is 5. So what will be the time complexity of this entire function? Or it will be 5n, right? For a single subsequence. So how many subsequences are there? 1,000. So this would be the new time complexity of your solution, 5n into 1,000. Now if you look at the constraint, n is 10 to the power 4, and if you multiply by the 10 to the power 3, it is 10 to the power 7, and there's additional factor of 5 as well. So 5 into 10 to the power 7, it is at the verge of the time complexity, like at the very edge. So you have to implement it uh, very carefully to make it pass, because it is at the edge of the time complexity, right? So any extra uh, operation can lead to TLE. Okay, so this is good. Like you can implement it. I'm not sure if this would pass or not, because the contest is still running, and I'm not sure if like if others are possible, if others have are able to solve this or not with this particular approach. So we'll look at it, and I will post a comment if they are able to solve it, and I will post a solution as well, or I will also try after the contest. So for now, this solution would work, but we can actually optimize it, and the way to optimize it is very unique, or very special, in the sense that you can apply the same trick in various other problems as well. So the technique is meet in the middle. Okay, so don't worry about the name. The name is just fancy. It basically says that if you have a bigger problem, right? Uh, we have a problem where we have the three distinct characters, right? If you have bigger problem, or we have problem where we have to find out the subsequence of length 5, or we have to match the subsequence of length 5. So the concept is very similar, very simple. The concept says that just divide the problem into two parts, right? And like divide the problem into two parts, and divide the sample space into two parts as well, right? So for example, let's say you have n characters. Okay, let's talk about this. Let's say like forget about these two things, or let me just sorry. So let's just hide these two things first, and let's focus on the technique first. So we have to find out the subsequence of length 5, or palindromic subsequence of length 5. Okay, now the problem says that just divide your sample space into two halves. Okay, now these two halves can be different, like you we can add. So what we will like, what it says that, let's say you divide the sample space like this. The first half is this, second half is this. Okay, now if you do this, just solve the problem for the first half. Like just solve the smaller problem for the first half. Let's say you divide the sample space into this, and the problem is you have to find the subsequence of length 5. So you can just assign that, okay, I need to find the first two character from this particular part and the last three character from this particular part. Okay, let's say there are x number of ways to form the first two character from this part and y number of ways to form the first last three character from this part. So what is the total number of ways? Total number of ways is simply x into y, right? So that's the problem. So problem basically what you're doing is you are actually dividing your problem into two parts. Those two parts can be equal or cannot be equal. Depends on you how you are solving it and what is the context in the problem. So you can divide the problem into two parts, solve them independently, and just find out a way to merge them. It is very similar to divide and conquer. Just uh, just you are applying it in a non-obvious place. Okay, so the technique is this simple. Now let's look at how we will apply this technique here. Okay, so if you remember, we have to form palindromes, right? And because we have to form palindromes uh, of length 5, right? So these two character and these two characters should be equal. So that's fine. So that's where there are total 10 to the power 2 possibilities of this character, and there are 10 possibility of this character. Now these two character, there is no possibility because whatever you will put here you will have to put here, and same goes for this. Okay, so these two we are ignoring for now. So like similar to this, you can like completely ignore this particular case, or you can say that, okay, find me, you can just say I will divide the sample space into let's say up till here. Okay, now I will say find me the number of ways in which I can form these two character from this sample space and these two character from the remaining sample space. Okay, and you can, because you are dividing, like you have to take every possible combination, right? The first part you can take this, the first part you can take this, right? First part you can take this, first part you can take this, and so on and so forth, right? So basically you will try every possible first part, uh, or basically that is one possible case. You can try every possible first part, but that will be complex, right? So instead what you can say, middle character I will fix. Let's say this is the middle character. Okay, now if this is the middle character, you know this is the left part and this is the right path, right? So what you need to do, you need to just say find me the number of ways in which I can form a particular string from the left part, number of ways in which I can form a particular string from the right part, and we will just multiply them to get the final number of ways in which this particular string can be formed. Okay, so hope this makes sense. So what you're doing is, instead of 1000, we are removing 110 from here by saying I will be fixing the middle character. Okay, now if I fix the middle character, I exactly know this is the left part and this is the right part. Now I just need to find out how many ways are there that I can form this particular subsequence, whatever, like there are total 10 to the power 2 combinations, right? This particular subsequence from the left part and this particular subsequence from the right part. For example, you can just say find me number of ways in which I can form 0 1 from this particular subsequence and 1 0 from this particular subsequence, right? And just multiply them, multiply the number of ways to get the final result. Okay, so hope this makes sense. So how it will look it in the code, there are two subsequences, forward subsequence and backward subsequence. So basically we just naming it forward subsequence and naming it backward subsequence, right? And if you remember, we already have a function that takes in s of index and sub index. So this sub index would be similar, like it will be 0, it will start from 0. S of index will be two different things. In first case, like in the left, in the right case, it will start from here, we'll start s of index from here, and the left case will start from here, but we will keep a counter that I need to go only till here because this is my string. Okay, so hope this makes sense. Let's look at the pseudo code which will make things clear. The major idea here was we will fix the first character, and once we fix the first character, the left sample space and the right sample space are separated. Now we just need to find out how many ways are there to form the uh, number of ways to form the left sample, the left part of the palindrome from the left sample space and the right part of the palindrome from the right sample space, and we'll just combine them by multiplying the number of ways. Okay, so what would be the time complexity now? uh, Notice that you are now finding out, you are now calling this particular count subsequence only 10 to the power 2, only for 10 to the power 2 substrings, right? And each of them has length 2. Previously each of them was of length 5, and you were calling it for 10 to the power 3 substrings, right? But now each of them are of length 2, and you are calling it for 10 to the power 2. So complexity would be 10 to the power 2. And for like these are the number of number of palindromes for which you are calling this particular function. And what will be the complexity of this particular function? Number of different states, which is x index is n, and sub index would be 2, because you are now finding the subsequence of length 2 only, right? So this would be the time complexity, and you have to do this twice, first for the forward and second for the backward, so multiplied by 2. So that would be the final time complexity. Okay, so let's look at the code. Like, if you are not able to understand it, just rewind the past 5 or 10 minutes of the video. Make sure you understand this particular piece completely. And once you have found, once you understand this particular piece, the rest is simple. We just fixed the middle character, and because we fixed the middle character, the left sample space and the right sample space are completely separated, and we are calling the same function for both of them. Okay, so let's look at it. So this is the code. Okay, so we look at upper half first. We are doing initialization, and initialization, uh, we are finding all the subsequences, so all the 10 to the power 2 or 100 subsequences. So for like 0 to 10, 0 to 10, just append them and form a particular string, and just append the string to our subsequences array. Okay, and the next is we are initializing dp with -1. So we'll look at what forward dp and backward dp are. We are just initializing them with -1. Okay, now this count palindromes, uh, we are calling initialize, like initializing the dp and the subsequences array. We are we are initializing our string as well as with the given string str. And finally what we are doing is we are for like we are fixing the middle index as we discussed. So middle index can be can start from 2 and go all the way up to n minus 2, because there should be two indexes before it and two indexes after it always, to form a valid palindrome. So we are starting with 2, ending with n minus 2. Now for the left half, we are saying, uh, this is the left end, or we are saying that this is the left end, this is the ending index. Find me the number of ways in which I can form this ith subsequence. Notice that we are iterating over all the subsequences array, so we are actually iterating over all the 100 subsequences. So we are saying, find me the number of ways in which the ith subsequences can be formed from the later half of the array. Find me the number of ways in which I can form this ith subsequence from the first, like before half of the array. And finally we just multiply them and take it mod and just sum it up. So this is the code logic. Now this forward and backward subsequences are exactly similar to the algorithm that we discussed, this particular algorithm. Let's look at it. So if we, let's first look at the backward. So this actually says, uh, so remember that we have to find something for the ith subsequence, right? So we just take the subsequence index. But what is the subsequence? Subsequence is subsequences of subsequence index. So that is the actual subsequence, right? Now once we found the subsequence, we just check whether the sequence is ended or not. If it is ended, return 1, because we have formed a valid subsequence. If it is if the string itself ends, we return 0. Now this -1 is because we are moving backward. This backward is for the second piece, like this left half piece. So from here what we are doing, we are going backwards. So in this particular thing we are going forward, right? Like we are just saying that the remaining string is this. And in the left half we have to go backward. So that's where we are checking -1. We will look at the forward sequence, that will make things clear, but that's the core logic. Now after that, we just, this is the memorization stuff. And we, as we discussed, there are two possible cases: skip the index, and if we skip the index, then remaining string is s index -1, right, because we are moving backward. And if we take the current index, and when can we take the current index? Only when the subsequence is equals to the current string index. And if they are equal, we can take the current index. And if we can take the current index, we will just take it and uh, move forward. And move forward means here just a -1. Okay. So this is a backward subsequence. Similar to this is the forward subsequence. So here we are starting with this particular index. Here we are in, like in the previous backward subsequence, we are ending at a particular index. But in forward, we are starting at a particular index, right? Hope you see the difference. So this condition is exactly same. The subsequence is completely exhausted or not. And this slightly changes because previous, if you look at the backward, this was s index -1, but now it is s index sn, because we are going forward. So we will hit the dead end at the last index, right? So that's what we are doing. If we didn't, we just return 0. Otherwise, as usual, there are two choices: take it or don't take it. If you take it, if you don't take it, just move ahead with the next index. If you take it, move ahead with the next index with the next subsequence, uh, next character of the subsequence, right? So hope this entire solution makes sense. If you have any doubts in this particular solution, please post them in the comment section below. I would be happy to answer. I'm sure there are other possible solutions for this problem as well. You can just avoid this entire thing, and you can just solve how many ways are there. I can form a particular subsequence from a particular prefix. You can solve it via uh, a for loop as well, because here length is 2. But if length increases, that will not be possible, and you have to apply a recursive logic here, something like this, right? So I would encourage you to think about it when the length is, let's say, 7 or 9 or something like that. And we can discuss the solution in the comment section below. Okay, so hope you like it. If you enjoy it, give it a thumbs up. If you like the channel, do subscribe to the channel. I am posting these kind of solutions with intuitions every week, and I hope you will be benefited from it. And I will see you in the next one. Thank you.